You blinked on January 1st, and suddenly it's now. Over half a week has passed by without you even noticing. How? Are days somehow shorter? Does a year pass like a season used to? Doesn't it also feel like your birthday is coming up with unusual frequency? Well, science has already confirmed that human perception of time appears to be accelerating across populations. When researchers ask people to estimate the length of a year, the answers are getting shorter. When they ask people to describe their sense of time speed, the words are getting more urgent, rushing, blurring, collapsing. Of course, the Earth still rotates in 24 hours. The neurobiological reality, however, is that human time perception is undergoing a measurable neuropsychological shift. To understand this, we're going to look at three interconnected systems in your brain that amplify each other in a self reinforcing loop. First, we'll look at neural pathway optimization, how your brain literally wires itself to process familiar things faster, which makes routine experiences feel shorter. Second, we'll examine memory architecture, how your hippocampus decides what to encode in rich detail versus what to compress into a vague blur. And third, we'll explore attention economics, how your brain's limited resources are being hijacked by predictable digital environments. In the modern day world, with all these routines and cheap distractions, these three mechanisms multiply and create what scientists call a feedback loop, where each system speeds up the others and creates that feeling that life is accelerating away from you. It is not an illusion at all. It is simply a predictable output of how your brain adapts to modern life. So let's begin the investigation. We're starting with the fundamental mechanism that makes your brain faster at the cost of making time feel shorter. At the very foundation of this mystery is something neuroscientists call Hebbian plasticity. You might have heard the phrase before, neurons that fire together, wire together. But what does that actually mean for your experience of time? Think of it like this. Every time you learn something new, your first drive to a new job, your first time navigating a new app, your first attempt at a new recipe, your brain has to activate a massive, distributed network of neurons. It's like exploring a wild forest with no trails. It takes time, it takes energy, and your brain has to work hard to coordinate all those signals. This high metabolic cost translates directly into a rich, detailed, slow feeling experience. Exactly. Novelty makes time feel fuller because your brain is working harder. But here's where it gets interesting. As you repeat that same experience, day 2 of the commute, week 3 of using the app, the 20th time making that recipe, those same neurons keep firing in the same pattern. And according to Hebbian plasticity, they start to physically change. The connections between them get stronger, and the brain cells wrap themselves in a fatty substance called myelin, which speeds up electrical signals by up to 100 times. This means that when your brain runs on these efficient, myelinated highways, experiences require less conscious effort. You're not actively learning or deciding, you're simply on autopilot. And here's the thing, tasks that demand less conscious engagement leave fainter traces in memory. It's not that the clock ticks faster in your brain as much as it's that when you look back, there's less memorable stuff to account for that period. The feeling that time flew by is often the feeling of cognitive ease. This will sound like a paradox, but basically, the more efficient your brain becomes at processing your routine, the less duration that routine occupies in your conscious awareness. You're literally getting so good at living your life that you're experiencing less of it, which is why it feels as though time is moving faster. This mechanism connects directly to our second system, memory architecture, because when your brain stops working hard to process experiences, it also stops encoding them in rich detail. The hippocampus is your brain's memory wizard. It's constantly making decisions about what to save in high definition versus what to compress into a vague blur. And it uses a process called pattern separation to make this call. You see, when you experience something genuinely novel like your first trip to a foreign country, your first time trying a completely unfamiliar skill, your hippocampus goes into overdrive. It allocates massive encoding resources to create rich, detailed memory traces packed with sensory data, emotional context, and temporal markers. This is why you can remember what you ate for breakfast on a special day 10 years ago, but you have no idea what you ate for breakfast last Tuesday. Novelty creates high resolution memories, and high resolution memories create a rich, full sense of time when you look back on them. But as you can already tell, repeated experiences trigger something called pattern completion. Your hippocampus recognizes them as already categorized and essentially says, "Oh, this again. I don't need to waste energy encoding this in detail." It allocates minimal resources to create a sparse, generic memory trace that barely registers in your consciousness. The consequence of this is exponential memory compression. Let me show you why this matters so much for our 2026 question. As environmental novelty decreases thanks to algorithmic curation, predictable routines, and digital echo chambers and predictive algorithms increase, we face a critical tipping point. Who knows? A year of your life in 2026 might feel like 6 months of your life in 2016. And this memory compression creates a vicious cycle with our third mechanism, attentional resource allocation. Because when your brain knows it's not going to encode something in detail, it also stops paying attention to it. Your brain has a fundamental operating principle that most people never learn about. It's not a passive receiver of information as much as it's a prediction machine. Every moment, your brain is generating a model of what should happen next and then comparing reality to that model. When environmental stimuli match your predictions perfectly, when the scroll feels the same, when the news confirms what you expected, when your routine unfolds exactly as planned, your brain's attentional resources are minimized. This is called inattentional blindness and attentional blink suppression. Your brain essentially says, "Yup, this matches my model. I don't need to waste energy here." But when predictions fail, when something unexpected happens, when there's a mismatch between expectation and reality, your attentional resources spike. You become hyper aware, time seems to slow down, and you encode every detail. This is why a car accident that lasts 3 seconds can feel like it took 3 minutes. Your brain throws all its resources at the unexpected event. Now, here's where our modern environment is perfect for making time feel fast. Our digital spaces aren't necessarily predictable, but they are designed to be low friction and endlessly absorbing. The swipe or scroll model creates a seamless, effortless stream of consumption. Again, this doesn't mean you can predict what you'll see next. You might be constantly surprised or spooked, but it minimizes the effort required to seek new stimulation. Let me make this simpler. When you scroll through Instagram for an hour, you're in a state of passive consumption. Your attention is scattered, and so you're not forming deep memories. That hour leaves little in terms of actual memories, so it feels like 5 minutes, if not even less. Now, contrast that with an hour spent hiking an unfamiliar trail. Your mind is fully locked in, and you're forming rich, detailed memories. That hour feels full and long because it was full, cognitively speaking. On the other hand, check how many hours you have spent on your mobile since 2026 started and check how many of those you remember. Now, having gone over neural efficiency, memory compression, and scattered attention, we can assemble the complete picture. When you do something on autopilot, your brain doesn't encode it in detail, and because it's not encoded in detail, it doesn't grab your full attention next time. And with your attention elsewhere, you engage with it even more on autopilot, and the loop continues. It's a cycle that feeds itself. A habit of passive routine engagement trains your brain to expect and create more passive routine experiences, which makes it feel as though time is actually moving faster. So, how to reset time back to its usual pace? Well, the cycle is a habit, and habits can be changed. The brain's great strength is neuroplasticity, its ability to rewire itself based on what you do. The very same principle that created this time compressing loop can be used to break it. If passive, effortless consumption makes time vanish, then active, effortful engagement can stretch it back out. Come on, it's the big 2026. The mainstream internet has betrayed us. If we don't consciously intervene, the cycle will only spin faster. So, let's restate the thesis with what we've learned. The clock is still the same, but our experience of time is shaped by the quality of our mental engagement. When our days are filled with efficient routines, passive consumption, and sparse memories, we look back and see a blur. Time feels fast because we were cognitively absent for so much of it. Of course, putting all of this into words is also the first step toward taking back your time. It means you can design your days to include more of the things that create a rich sense of duration, novelty, challenge, and deep focus. Now, if you enjoyed this video, I'd love a like and a comment that furthers the conversation, and also look forward to my next video where I go over the only brain habit you need in 2026 to completely change your life. Spoiler alert, it's not what you think it is.